This video covers my predictions for the AQA trilogy combined science paper for physics for this summer 2024. It looks at the paper 1, which is going to be sat on the 22nd of May. It's a 1 hour 50-minute paper and there's up to 70 marks. Now, as a disclaimer, I don't know what's going to come up, but I have looked at the past sort of 5 or so years worth of papers, and I've written down what sort of topics come up a little bit, and these are the ones which might come up this time because they've not been examined for a couple of years. However, I don't know for certain, so please revise all topic areas. So firstly, to look at is resistance. Now this will cover the required practical of the length of wire required practical, so please look at that in detail. Think of your variables, your independent and dependent variables and your control variables. But questions on resistance, either the equation or within series and parallel circuits, there tends to be always a question on a resistor or resistance. So please have a look at those. Likewise, pressure. There seems to be a question in pressure in some form or another in most papers. So maybe we can expect that again, that pattern and that trend. So that's explaining what pressure is, maybe in a 2 or 3 mark question, but also in different various contexts as well. So these two always seem to appear. Then we have atomic structure. Now, atomic structure will look at the changes of the atom, atomic timeline theory, but also the structure of the atom as well. So we've got the nucleus made up of protons and neutrons with electrons in energy shells, orbitals going around it. So be prepared to see a question on atomic structure, and linked to that, of course, we have kinetic theory, especially solids, liquids and gases. Again, this could be a 3, 4 mark or 5 or 6 mark question, really explain the differences between solids, liquids and gases. Watch out for if you have to draw a particle diagram of a liquid, that you have at least 5 circles, those are your particles, and they are touching. Then we want to really think about heat transfer and energy transfers. So your heat transfers, conduction, convection and radiation, but also linked into energy transfers as well. And remember the idea of dissipation of energy that is dissipated into the surroundings. Then current voltage graphs. Remember the current voltage graphs for like a diode or a filament bulb or a fixed resistor. Make sure you can see the patterns for those and you can spot them and be able to draw them and explain the data behind them and why the graphs look like they do. Decay equations. So that's looking at alpha decay and beta decay. What does that parent nuclei turn into after we have some emission of alpha particle or a beta particle? Remember, an alpha particle loses 4 from the mass and 2 protons, and the beta particle, the electron, obviously it's a high speed, high velocity electron that isn't from the energy levels around the nucleus, it is from the nucleus, where a neutron gets turned into a proton and an electron. The electron is emitted out, but that proton remains in the nucleus. And so the nucleus mass number does not change, but the proton number will increase by 1. Electrical safety. Look at your 3-pin plug. What are the safety features of the 3-pin plug? How else do we make electrical circuits safe? Alpha, beta, gamma comparison. So linked in as opposed to the decay equations, what is the difference between alpha, beta and gamma radiation? Can you compare and contrast? How are they similar? How are they different? Which is the most ionizing? Which is the most penetrative? Remember, we do not explain or describe alpha, beta or gamma in terms of being a stronger type of radiation. It's how ionizing it is or how penetrating it is. Density. This quite commonly is a sort of 5 or 6 mark question. How do we find out the density of a regular shaped object, a regular shaped object, or a liquid object? But also, it might have questions on the calculation there. Remember, it's mass divided by volume. Then we have the latent heat and heat capacity equations. This could be a multi-step equation where you have to work out the mass of a substance, of a melting substance or a melted substance by using the latent heat and the heat capacity equations. And think about as well the relationship between potential energy and kinetic energy and how that is transferred. Like I say, these have not been tested in fully for a couple of years, so they may pop up this time round. If they don't blame me. Revise all the topics fully, but these are some of the things which may or may not appear on the paper. Good luck.